8. Question 8. The photographer shows a theme park ride called the Aqua Shoot. Riders of the Aqua Shoot sit on a sled and move down a slide. A light gate and a data logger can be used to determine the speed of each rider and sled. What two measurements are needed to determine the speed of the rider and sled? All right, well, this is actually a practical on paper 2. It's the one that proves one of Newton's laws, that F equals ma practical. So basically, you end up with a data logger, and the way that it works is you've got your object. You normally put this on a ramp like this, and the car would go through the object. And what you have is your car. You have a piece of card on it, and the whole way that this works in terms of determining the speed is we use that speed equals distance divided by time. So this card, you know the length of it, that's your distance, and the time is how long it takes to pass through the light gate. So let's have a look. What two measurements are needed to determine the speed of the rider and the sled? Well, it's the length of the sled, because that's the equivalent of the length of the card, and the time to pass through the light gate, because it's speed equals distance divided by time. The decrease in gravitational potential energy of one rider on the sled was 8.33 kilojoules. Let's write that down. The rider moved through a vertical height of 17 meters. All right, we've got a bit of a disagreement here with units. Meters, if that's in meters, then this should be in joules, not kilojoules. Let's fix that now. So 8.33, to get it into joules, we have 1,000 joules here, so kilo is 1,000, so we're just going to times it by 1,000. And if we times it by 1,000, I say, always use your calculator, even if you think it's really easy to do it. So 8.33 times by 1,000 is 8330. 8330 joules. 70 meters. And the gravitational field strength is 9.8. Calculate the mass. Alright, so we have a mass, we have gravity, we have a height, and we have here an energy. So we're looking for a formula that links energy, height, gravity, and mass. And ideally, mass would be the subject, but it's worth 4 marks. So there's probably going to be some rearrangements to be done here. So we have to use all of FIFA. We're going to have to fine tune it. So let's grab the data sheet, and we're looking for energy, height, gravity, mass. Okay, take off this. Always start at the start. Okay, that was pretty straightforward. And the one I was looking for is this one. Energy, mass, gravity, and height. EP, mgh. So energy potential is mass times gravity times height. So let's write our formula in. Just going to move this so that I can use all the lines. So the formula, energy potential equals mass times gravity, or gravitational field strength, times by the height. All right, let's input the data. So the energy we know is 8330. The mass we don't know, so we'll leave that as mass. Gravity is 9.8, and the height is 17.0. All right, so we are going to have to fine tune this because we want to make mass our subject. So mass is currently being times by 9.8 and by 17. So we can just divide this side, divide the mass by 9.8 times by 17.0. We'll do the same on the other side, so divided by 9.8 times 17.0. And if we do that, that will rearrange it to be 8330 divided by 9.8 times 17.0 is equal to the mass, because 9.8 above and below, 17 above and below, so we can cancel that out. All right, so let's do that to get our answer. 8330 over 9.8 times by 17.0 gives us 50. 50 is a very appropriate mass for a person, so that seems sensible to me. If I got something like 5,000 kilograms, I'd be questioning my answer. 50 sounds sensible. All right, just check it out all over again, but I'm pretty happy with that as 50. Okay, at the bottom of the slide, all riders have and sleds have approximately the same speed. Explain why. All right, this is a 4 marks for doing this question, so let's really think about this one. So an explain is to give our scientific reason why. All riders and sleds. Now, it's probably easier to show this one by using formula. Let's have a look. So because at the top of the slide, and I'll draw a little diagram. So at the top of the slide, we're talking about energy potential, and at the bottom, we're talking about energy kinetic. So AP equals mass times gravity times height, and at the bottom, we've got energy kinetic, which is, oh, not from there, from here. This one, the top one, half times mass times velocity squared is half times mass times by velocity squared. So let's have a look. So we can see, because we're using these two formulas, the energy is going to, the energy is going to be the same if we imagine the energy transfer from there being the same. So that energy can cancel with that. The mass is there on both sides as well, so that mass is going to cancel on both sides. So we're going to be left with a formula here, which is going to be that v squared is equal. So this is equal in here. So rather than having, you could say that half times v squared is equal to gravity times by the height. Or we could say that we could times out that half. So if we're going to times that side by 2 to get rid of the half, times by 2. So v squared is going to be equal to 2 gravity times by the height. So what that's telling us is that therefore if we want to square root that out, so the velocity is equal to 2 times gravity times by the height. So basically, with that big long figuring stuff out, it says that all riders and their sleds have approximately the same, because the speed is only dependent on the gravitational field strength and the height. So we could say that we'll just create another box here. So the speed, or the velocity, depends only on the gravitational field strength and the height of the were they on a ramp or something? The height of the ride. So speed depends only on the gravitational field strength and the height of the ride. As all riders are on Earth and the ride height is constant, all riders will have the same final velocity. So mass will not affect the speed. The only thing that would affect the speed is taken outside of that formula is if the idea that people mean different shapes, so air resistance might be different. But I think that explains it. It's important to have this idea of your formula shown down here. It's rare you get an exam question like this where you have to take these two formula, but so the advanced information does say there's a lot of stuff in with energy and linking energy transfers. So you can do this quite easily. It's just you take the two formula from the moving down, and we just cancel all the bits that are in both formula, and then you can use that to produce a new formula or derive a new formula. And then if you just take that to the extreme, then you end up working out exactly what V is equal to. And as I say, it has no effect based on the mass. Its only effect is the gravitational field strength, and the rides are, I imagine, all happening on Earth, and the height of the ride, and the rides, or if the rides all start at the same height. So yeah, that's the only thing that will affect their final velocity.